All right, sorry guys for the little break. I had to get my daughter on the computer for a second. So if you take a look at this, guys, number 4, we have 2 sine theta minus 1 is equivalent to 0. Now, the difference here is that our trig equation, our trig function, sine theta, is not isolated. So goal number 1 in a problem like this is to first isolate that sine theta. So that is our goal right now. So if I want to isolate that sine theta, what I'm going to do is I'm going to first, again, we do the same thing we do with every other equation. We move addition and subtraction first, and then you divide by the number attached to the trig function. So in this case, I would first add the 1, and I would get 2 sine theta equals 1, and then I would divide by 2, and I would get sine theta is equivalent to 1/2. Because the 2's on this side would cancel out. Now, again, we have sine theta. So now sine, again, remember, sine of theta equals y. So when we go to our unit circle, we are looking at y. When is y 1/2? And if I think about it here, sine is positive. I should know that I'm going to have a positive sine value when in quadrant 1, because everything is positive in quadrant 1, and in quadrant 2, because sine is positive. So I'm looking for that positive y value. And if I bring my unit circle over and I look for a positive 1/2, I right here at pi over 6, I have that positive 1/2. And at 5 pi over 6, I have a positive 1/2. So on that interval between 0 and 2 pi, they would be my 2 answers. So I would say theta is equivalent to pi over 6 and 5 pi over 6. They would be my 2 answers. All right, guys? So if I take a look there. All right, these are my 2 answers. All right, so now what I'm going to do is let's do a couple more, and then I'm going to give you an assignment for tonight with a couple problems. So I just want to make sure that we can see. All right, the next problem that we're going to do is slightly different, maybe a little more. Actually, we'll do one more like this. Now I'll do this. This is a little more tricky. So let's do this problem. So that was, I don't like my numbers off. 4, so we're going to do 5. This is the 5th problem I'm doing, guys. So if I take a look here, I'm going to have 2 cotangent theta plus 1. So guys, the difference with this one is, and it equals negative 1. Cotangent I'm giving you here. So if I give you cotangent theta, this is slightly different than what we just did, because cotangent is going to be x over y. So that's what we have to be aware. We're looking for x over y. So first, again, we are going to isolate that trig term, cotangent theta, that trig function. That's going to isolate that first. We're going to move the 1. So you get 2 cotangent theta, and we subtracted it, negative 1 minus 1, negative 2. And then divide by the number in front of the cotangent, because they're brought together by multiplication. So I'm getting cotangent theta is equivalent to negative 1. Now let's think about this. Cotangent is negative. And again, that cotangent is the reciprocal of tangent. So when tangent is negative, cotangent will also be negative. So all students take calc. So when I look at this, when is tangent negative? Tangent will be negative in quadrant 2 and quadrant 4. And when I want cotangent to be negative 1, in order for cotangent to be negative 1, if we think about it, you need to have x over y. X over y would have to simplify to that negative 1. So that means they'd have to be the same exact value except differ by a sign, meaning one would have to be the opposite of the other. So if I take a look at this problem now, and I want to say, how can I do that? Now, we already said we're looking in quadrant 2 and quadrant 4. If I look at this, here my x and y values are exactly the same. However, one is negative, one is positive. If I put x here, square root of 2 over 2 over root 2 over 2, that's going to simplify to negative 1. If I put root 2 over 2 over negative root 2 over 2, that's going to simplify to negative 1. So therefore, at 3 pi over 4 and 7 pi over 4, I will have a cotangent value of negative 1. Now, that means those would be my 2 answers on that interval. between 0 and 2 pi. All right, guys? All right, let's take a look. Let's see if I can find another one that we can take a look at. All right, let's take a look at a cosecant one. We're going to do 2 more, guys, before I give you some problems. All right, let's take a look at here. Cosecant theta plus 1 equals 3. Now, if we take a look, cosecant, first thing, I'm going to subtract that 1. Cosecant theta equals 2. Then we need to ask ourselves, what does cosecant represent? Well, cosecant theta, what does that represent? That is 1 over y. Now, because it's 1 over y, right, that means 2 has to be equivalent to 1 over y. Now, sometimes that's difficult to just go from there. So, my advice is to use this trig identity. We know cosecant is the same as 1 over sine theta. They are reciprocals. So what I can do is I can take the reciprocal of both sides. And by doing that, watch what happens. The reciprocal of cosecant theta would be sine theta. The reciprocal of 2 would be 1/2. Now, if I do that, I take the reciprocals of both sides, I have sine theta equals 1/2. This is easier to work with, because that means sine theta is equivalent to y. And I'm now just looking for when y is 1/2. So again, I'm going to go to my unit circle, and I'm going to say, when is y 1/2 on the interval between 0 and 2 pi? So I'm looking for 1 revolution. So when is y 1/2? Well, it's 1/2 here at pi over 6, and it's 1/2 here at 5 pi over 6. So those would be my 2 answers. So it would be theta is equivalent to pi over 6 and 5 pi over 6. All right, guys? All right, I'm actually, let's do one more, like I said. Let's do one more. All right, guys, let me make sure you can see it. All right, it should be 5, 6, 7. All right, guys, so here, my last one that I'm going to do today is 2 secant theta plus 1 is equivalent to secant theta plus 3. Now, this is slightly different because we have 2 secant terms. But what our goal is going to be is to move both secant terms to one side. So in this case, I'm going to actually subtract this secant theta. And you're going to treat it like an x variable, meaning 2x minus x would be x. 2 secant theta minus secant theta will be secant theta. Now, it's plus 1 equals 3. Now I'm going to subtract that 1. And I'm going to get secant theta equals 2. We are going to use the same exact strategy that I used up here. We're going to take the reciprocal of both sides. Now, secant, the reciprocal of secant, remember, secant theta is equivalent to 1 over cosine. So its reciprocal will be cosine. So the reciprocal of secant theta would be cosine theta. The reciprocal of 2 is 1/2. This is easier to work with because we know cosine theta equals x. So now I'm saying, when is cosine 1/2? Well, we know cosine is positive in quadrants 1 and quadrants 4. So now let's take a look at my unit circle. Cosine is our x. When is x 1/2? It's 1/2 at pi over 3, and it's 1/2 at 5 pi over 3. So theta equals 1/2 is pi over 3 and 5 pi over 3. All right, guys? Now, those are a couple problems that I went through today. And what I would like you guys to do, there's an attached worksheet that will be your homework for tonight. It will be due at 8 p.m. tomorrow night. If you have any questions, please attend office hours tomorrow or today, and we can go over them. Try to find the copy of your unit circle. If you don't have it at home, it's totally okay just to go on the internet and take a look at what unit circle you have available to you there. All right, guys? I hope to see you at office hours. Talk to you soon. Bye.